This is Dr. Mark Trexler with the Climate Countdown, here to provide you with insights into some of the key questions and risks associated with our one-way planetary experiment, otherwise known as global warming. Today's topic, the climate implications of sulfur dioxide. Most coal, when burned, emits sulfur dioxide, or SO2, primarily thought of as contributing to acid rain. SO2 is not a greenhouse gas, but it does affect the Earth's temperature. That's because SO2 in the upper atmosphere turns into sulfate particles that form a reflective shield around the Earth, preventing a small fraction of the sun's energy from hitting and warming the planet. During the 1960s and 70s, some scientists hypothesized that coal burning might lead to the deflection of enough sunlight to trigger global cooling. That didn't happen in part because so many countries dramatically reduced SO2 emissions to reduce acid rain, and in part because the greenhouse gas emissions associated with human activities have simply overwhelmed the cooling effect of SO2. But a lot of SO2 is still emitted around the world, affecting global temperature. According to the Intergovernmental Panel on Climate Change, or IPCC, the Earth has warmed on average by almost 1.3 degrees Celsius since the 1800s, primarily from human activities. Note that 1.3 degrees of average global temperature change is uncomfortably close to the 2-degree official target established by the global community, not to mention the 1.5-degree aspirational target agreed to in 2015. Enter sulfur dioxide, which is counteracting some of the warming from greenhouse gases already in the atmosphere. If, hypothetically, coal use declined rapidly and the counteracting effect of SO2 went away, average global temperature would rise. The IPCC estimates that the cooling effect of sulfur dioxide is between 0.1 and 0.9 degrees Celsius, with a best estimate of almost half a degree. So eliminating SO2 emissions might cause observed average global temperature change to surge to between 1.4 and 2.2 degrees, blowing past the 1.5 and potentially even the 2-degree targets. You may be thinking, wouldn't reducing coal use slow future warming? Yes. But all we're talking about here is the greenhouse gases already in the atmosphere, not future emissions. Of course, coal use won't end overnight, so this is all rather hypothetical. And I'm not suggesting we keep burning coal. My point here is that there are important complexities associated with anticipating future global warming and its potential consequences. Others include the net effect of a warming atmosphere on cloud formation, the possibility of climate change tipping points, and whether the biosphere will continue to absorb roughly 50% of greenhouse gas emissions. From a risk perspective, and given the potentially massive consequences of warming the planet beyond anything humans have experienced before, uncertainties like these should make us more cautious about engaging in the one-way planetary experiment global warming represents. Unfortunately, uncertainty is frequently used as an excuse to not act. That's a mistake. Interestingly, there's a lot of debate today about the possibility of intentionally adding to the reflective shield we've been discussing here. So-called solar radiation management is one of a number of climate geoengineering strategies that advocates see as potential fallbacks if other efforts to mitigate global warming don't succeed. But like everything else, there is no free lunch here. Solar radiation management, for example, wouldn't do anything about the consequences of ocean acidification, and there are huge questions about how one would govern something as seemingly simple as flying a plane full of sulfur into the upper atmosphere. It's just one more of the risk trade-offs we're potentially facing. This is Mark Trexler with the Climate Countdown. Dig deeper into this and other Climate Countdown topics at our website, climatecountdown.climatesites.net. And thanks for listening.